So taking a look at a few more balancing chemical or redox equations. Here we have copper with nitrate. The copper solid has an oxidation number of 0. Copper ion has a charge of +2 because of the +2 charge, and the copper metal is in its elemental form. That's why it has a charge of 0. We do need to figure out the charge here of nitrogen and the oxygens. It is a little bit cut off here, but this is a NO, just NO gas by itself. Oxygen is -2, so nitrogen is +2. On the other side, we have the nitrate. You might remember nitrate from another example, but oxygen's here is -2. -2 times 3 is -6. There is a -1 here for the charge. That's what nitrate's charge is. So we need a +5 charge in order to have our oxidation numbers work out. So let's zoom in a little bit. Okay, so we have to identify changes in charges. So copper is changing from 0 to +2. So in order to go from 0 to +2, we need to lose electrons. Losing electrons is oxidation. And then the nitrogen is going from +5 to +2, which is going to be referred to as reduction. Gaining electrons is reduction. So Leo and Ger kind of is a way to help you remember this. I always remember Leo and Ger and think it in my head as I work through these types of problems. So now what we're going to do, we're going to split up our reactions into the two parts. So I always start with whatever is first. So we have the copper going to copper +2. So first thing we have to check is everything but O's and H's. Is everything but the O's and H's balanced? And in this case it is. Copper, we have 1 copper on each side. After we check that, we check for oxygen. There's no oxygen, we don't have to worry about balancing it. Also no hydrogen, so we don't have to worry about balancing it. After we go through and balance those 3 things, we want to take a look at the charge. We have to balance the charge. So right now, the reactant side has a 0 charge, and the product side has a +2 charge. So in order to get these to balance out, we have to add 2 electrons. So they don't have to be 0. In this example, they are, but they have to be the same. So we added 2 electrons to the product side. So we're now going to take a look at the other reaction. We have the nitrate ion going to nitrogen and oxygen. So we follow the same steps. So everything but O's and H's balanced, which in this case it is. Nitrogen is balanced. Oxygen, however, is not. So in order to balance the oxygen, we have 3 on the reactant side. We're going to add 2 waters to the product side to give us a total of 3 oxygens. Now that oxygens are balanced, we're going to add 4 hydrogen ions to the reactant side. 4 hydrogens on the reactant side balance the 4 hydrogens that we added to the product side. Now remember, this is happening in solution. The addition of water isn't going to be something that's super noticeable. You're in a solution to start with, so that's one of the reasons why we use it. And there's also hydrogen ions there too, so you're not really making a huge change in your solution. Okay. If we take a look, everything's balanced. Now we can take a look at the charge. So the hydrogen will give us a +4. Nitrate gives us a -1. We then have a 0 and a 0. So overall here we have a +3 charge on the reactant side and a 0 charge on the product side. So we're going to add 3 electrons to the reactant side. I always like to leave myself extra space so when I start adding things I don't have to squish it in before I go any further. Notice if we compare the 2 reactions, we have the same kind of setup. Now for the copper we have electrons on the product side And for the nitrogen one, we have electrons on the reactant side. That's good. We want that to happen. Now, what we'll have to do, we have to make our electrons match. So in order to make our electrons match, what we're going to do, we're going to multiply the copper reaction by 3 and the nitrogen reaction by 2. That's the only way to get the same number in both. Just like with balancing, you can't use a fraction here. You can't have half of an atom. So we'll have 3Cu. So I like to rewrite them when I multiply so that I don't forget anything. Because when you do this, it can be easy to forget what you're multiplying because you're multiplying, especially when you have two separate numbers. When we get to this point, we now check to see if anything cancels out. The electrons have to cancel. If you have the hydrogen ions or the water on either side, they would cancel out here. But we don't have that in this reaction. So then what we do is we add our reactions back together. And we end up with that as our final answer. So yes, these problems are a little bit long. However, they follow the same process kind of over and over again. Okay, so we're going to look at the next reaction. We're going to follow the same process. Something you might notice here is that it says in basic solution. I'm not going to test you on ones that are basic. There's one more additional step, but you won't have to worry about that part of it. I'm just showing you just so you know. We're going to follow the same process though. We're going to go through and identify the oxidation numbers. The chromate or the chromium here is +3 because it's an ion, and then we're going to go through and identify everything else. So all of the oxygens are going to be -2, so it's -14 total here for the oxygen. So then the Cr has to be +14. There's 2 of them, so it has to be +7. So again, I had -2 from the oxygen. I know that because oxygen for us is always -2. Multiplied it by 7 to give -14. I have to add up to 0 here, so it has to be +14. And the chromium then, because there's 2 of them, has to be +7. So this one is a little bit trickier. And then we're going to do the same thing. So this is actually nitrite. Nitrite has NO2 -1. So I have a -4 from the oxygen, so the nitrogen has to be +4. Oh, nope, +3. I forgot the -1 charge. So we have the -1, so +3 -4 is equal to -1. Same process here for the nitrate, except now nitrogen is going to be +5, because again, we want to add up to -1. So we're going to identify what's happening here. So the chromium and the nitrogen are changing. Generally, it's usually not oxygen, but it can be oxygen. So chromium's going from +7 to +3. So that means we are adding electrons or gaining electrons, which is reduction. +3 to +5, we're losing electrons, so that's oxidation. So what we're going to do, we're going to then separate our half reactions. So I'm going to do chromium with the oxygen to Cr +3. So first step, making sure everything but O's and H's are balanced. In this case, the chromium is not balanced. So I'm going to add a 2 in front of the chromium. So now my chromiums are balanced. So it's very rare that the element's not balanced, but in this case it is, so it's something we have to remember. So next step, we have to balance our oxygen. So I'm going to add 7 waters. 7 waters balances the 7 oxygen. Now I have to balance my hydrogen. So I'm going to add 14 hydrogen ions. to the reactant side to balance the hydrogen ions that are here. And now I have to take a look at the charge. So we take a look at balancing everything but O's and H's, then balancing O's with water, balancing H's with hydrogen ions, then balancing the charge. So on the reactant side right now, I have plus 14, which is all from the hydrogen. On the product side, I have a 0, and then I have a plus 6 from the chromium. Because there's 2 chromium, I have to multiply the charge by 2. So it's not plus 3 from the chromium, it's plus 6. I have to get these to be the same charge on both sides. So what I'm going to do is I'm going to add 8 electrons to the reactant side. 8 electrons will make this a plus 6, so I have the same charge on both sides. So now we're going to deal with the nitrogen. So nitrite, NO2 minus 1 to nitrate. Notice how I'm not including the phases here. For us, we don't really have to worry about the phases. There's a lot of other stuff going on. So we're going to follow the same process. So nitrogen is balanced. That's the only thing we have that's not an oxygen or a hydrogen. So I'm going to add a water to the reactant side to balance the missing oxygen that's needed. So now I'm going to add 2 hydrogens to the product side to balance my hydrogens. So I'm going to take a look at charge now. So water is 0, nitrite is -1, nitrate also -1, and hydrogen is plus 2. So that means I have a plus 1 on my product side and a -1 on my reactant side. So what I'm going to do to balance this out, I'm going to add 2 electrons to the product side. That 2 electrons will make this a -1 charge. So next I'm going to multiply the nitrogen equation by 4 so that my electrons balance. That's what I'm trying to do. In this case, I only have to do the 1. I am going to rewrite it though to make this easier to cancel things out. When you're doing this, I always like to rewrite the ones I multiply. Oops, that's an electron. Just so that it helps me to one thing at a time. So we're going to cancel. When you cancel on your test, like for example here, with the chromium one, we didn't have to multiply it by anything. It's best to just use kind of a single line to cancel it out. You don't want to scribble it out because what I'm looking for, especially if you made a mistake, I'm looking for what you crossed out and I want to be able to see that what you crossed out. So a single line is fine because I can still see that you canceled it out and I can see what it is. So 8 electrons cancels out. That has to cancel. Now in this problem, I have waters and hydrogens that can also be canceled out. So I have 14 hydrogens on the reactant side and 8 on the product side. Since they're exactly the same thing, I can cancel them out. So I'm going to be able to get rid of the one there's less of, which in this case is 8 hydrogen, and change the 14 to a 6. So I have 6 hydrogen now on the reactant side only. And we do the same thing with water. So I have 4 in the second equation and 7. So the 4 is going to disappear. And I'm going to change up here to a 3 because they're canceling out. They're identical things, so they're canceling out on both sides of the equation. So just like before, we're going to add them back together again. So I have 6H plus Cr2O7 plus 4NO2 minus 1 goes to 2Cr plus 3. And the order here isn't important. The only thing that I'm looking for is that you have the things on the appropriate side of the arrow. So if you have reactants with reactants, products with products and you didn't forget anything. That's one of the more common mistakes here, is forgetting something from the previous reaction when you're adding them together. Okay, so right up to this point, this would be what I would expect you to do on a test. It's referred to as acidic conditions. In this problem, it's referred to as basic solution. So in order to have a basic solution, we do have to follow a few additional steps here. So a basic solution, we haven't talked about acids and bases yet, but when you have a base is referred to as a hydroxide, what you do is you add however many hydroxides to each side of the reaction, you add it to both. So I add 6 hydroxides because I have 6 hydrogen ions over here, and then add 6 hydroxides over here. As we know from our reactions, this would become 6H2O, which we can then, again, cancel with our 3 waters over here, make this 3. So these are both gone at this point. It is kind of one more step. This is just changing our pH to make it basic rather than acidic. So I would just rewrite it with everything. Again, canceled out. And we're doing this because it's a basic solution. I'm not going to ask you basic questions or basic redox problems on your test. I'm just showing you this so that you know kind of what happens.